So next we have a technical talk by our own Carly Jerman. She is a senior data scientist in Vanguard's Office of Investment Management, FinTech Strategies. She is going to go over her work on predicting ratings changes and partnering with individuals on Vanguard's trading floor. So Carly, just a quick reminder, keep your microphones muted and your video off.
Hi, everyone. Can you see my screen okay?
Yes.
Awesome. Well, hi, everyone. I'm Carly. Hopefully you know me by now, and I'll be talking about applying data science at Vanguard, as well as my role in the types of projects that I work on. First, I'll start off with an overview. I'll give an introduction to myself, my company, and my team. After that, I'll dive into an experiment that I'm currently working on right now to understand the problem and talk about the data and modeling steps involved. After that, I'll talk about the partnerships with my colleagues on the trading floor and describe the iterative approach to experimentation that I take with them. And then at the end, if there's time, I'll go into other types of data science experimentation that I've worked on and different types of applied data science in the space. A little bit about me. So I'm a senior data scientist at Vanguard. This picture is actually a picture of Vanguard's cafeteria, so that would be me on a nice sunny day if we were there without COVID. I have my Master's of Science in Management Science and Engineering with a computational social science concentration from Stanford University, where that's really an applied data science type program. I have a BS and BA from the University of San Diego in Industrial and Systems Engineering. And my past research has been on hospital bumped cases and water sanitation in the Dominican Republic. But today there are so many people here from different backgrounds, and I really want to highlight that there's not one direct path into data science. You can get there from many different ways. So my path actually started with culinary, where I thought that I was going to be a baker and create these large scale cakes. And I really enjoyed crafting them, figuring out how to make the cakes, and I was convinced that that's what I wanted to do. Then I realized, okay, well, you have to stand on your feet all day. It's quite difficult and quite stressful. So I thought I'll just go into the event planning side of stuff. So then I went to go business. I wound up getting an internship with the Chamber of Commerce to try it out. Turns out that wasn't for me either. I wound up switching over to architecture, kind of combining in that cake making again. Then realized that it wouldn't let me take enough calculus, so switched over to math and then somehow landed on the industrial and systems engineering path. I really liked that program, and there was one professor that really was phenomenal for me in operations research. So then I started applying to PhD programs in operations research, thinking that I could do optimization in space. I'm not sure why, but I thought that would be interesting at the time. Then managed to find my way into Stanford's Management Science and Engineering program, where I took one course on Introduction to Computational Social Science, pivoted my major away, and then wound up sticking with data science. I actually made my way to Vanguard because I met some individuals at just a lunch and learn, and then kept interviewing and talking to them then, and then now moved to Philadelphia to then work as a data science there. So everyone's paths are really different in data science, and I think that's something that's really interesting about the whole day today. Now, a little bit about my team. My team is called Investment Management FinTech Strategies. You'll also hear me call it as IMFS. This team's at Vanguard, and Vanguard's one of the world's largest investment management companies that offers a large selection of low-cost mutual funds, ETFs, advice, and other services. And so it's a massive organization with over 6 trillion global assets under management, with over 400 funds worldwide in 170 countries or so. And so within that group, there is a group called the Investment Management Group, and that houses the traders, analysts, portfolio managers, and folks who work on the trading function. And my team is within that group and partners with all of those individuals. So my team, IMFS, is a 20-person team of data scientists, engineers, and subject matter experts that work closely and on the same floor as both the traders and portfolio managers. The mission of our group is to explore emerging technologies that can dramatically improve investment performance or make capital markets work better for our investors. We also want to embed a culture of innovation across the investment management group and change the way that technology is applied there. My team experiments in 3 main areas. There's new insights, capabilities, and markets, all aimed at delivering new projects and initiatives for Vanguard's investment and portfolio management teams. So how does our team work? You see that logo that says think far and make it real. Vanguard crew, so the analysts, traders, portfolio managers, they wind up submitting ideas to our team. Those ideas can be anything small or large, all in the realm of technology and data science. We then research those ideas and determine both what's good and a feasible project to work on. And then we form cross-functional teams to actually combine business and technology and solve these applied projects for the desk. When we get these ideas, we know that they might not all have clear solutions. So this leads to the North Star experimental approach. And you'll see that image with a whole bunch of X's and check marks on the right side. Constantly, my team is trying new things, and new things mean you don't always have an answer. So many times my experiments will fail, but each time you wind up learning from that experiment and growing on it. So we call it like an iterative approach to experimentation, where you wind up, assessing at each point and then continuing on and expanding if need be. Enough about all of my background, but now I'm going to dive into an actual project that I'm working on currently to predict rating changes. This project idea came to my team when a portfolio manager reached out to my team to partner on this idea and make it a reality. And I've been working on this the past few months. It's been a really exciting project. Let's start off with some background. Companies get rated by rating agencies. 3 of those rating agencies are Moody's, S&P, and Fitch. These rating agencies help investors decide how risky it is to invest in a company or a bond by providing an assessment of its creditworthiness. These ratings help investors know how financially stable the company is that issued the bond, to understand if it's likely to meet its financial obligations, which is important for an investor because if someone invests in a bond, they want to get paid. Each of these rating agencies has a method to getting a rating, but each of those methods are slightly different from one another. However, the higher grades, like AAA, signify the highest investment grade and means that there's a very low risk, and the lower grades means that they're higher risk. So for example, Johnson & Johnson has been doing great for many years and great right now. So they have a really high rating at AAA. American Airlines has had a few things in the past that have made it a lot more risky. And so it has a lower rating of B-. And so other ones with a good rating are Microsoft is really great rated and Boeing isn't as great. So these are the different types of ratings that companies can get. How does this impact Vanguard? Rating agency actions, both upgrades and downgrades, can often result in significant market reaction. This is particularly true for fallen angel downgrades, which is when a corporation gets downgraded from investment grade, so that higher level, to high yield, which is the lower level ratings. Also for rising stars, which is the opposite, when a corporation gets upgraded from high yield to investment grade. Analysts spend a lot of time researching whether these ratings will increase or decrease. And it's important to know for many reasons at Vanguard. So what we can and we should include in our funds, because some funds can only hold the higher qualities. Predictions can also help know when to buy or sell. You can avoid spread widening with downgrades and tightening with upgrades. However, all of these problems are great to solve, but the main problem that this really is working to solve is that there are too many issuers and too little time. One of the key challenges that Vanguard has is having full research coverage across the investable universe. Because over the past 10 years, credit markets are growing significantly to 9 trillion across roughly 2,000 issuers, and they continue to keep growing. In addition, both the amount and type of data required to anticipate ratings actions is growing exponentially. And that's really where I come in with those 2 last things. As there's more issuers and as there's more data, what can we do with this? Now for the hypothesis that we're trying to solve. Looking at everything that we know now, can we predict whether a company's rating will increase, decrease, or stay the same? We're working with the trading floor, so we want these predictions to be explainable and understandable. And history suggests that markets price these rating actions in, on average, around 6 months in advance. So we want to test out 3 months prior, 6 months prior, and 1 year prior to be able to compare and contrast and see what prediction time window works for us. This can be used for many things. So idea generation, helping identify upgrade and downgrade candidates that weren't previously considered. For focus and prioritization, filtering down the universe, enabling analysts to prioritize time on the more impactful credits. Also, the objective data can help reduce bias and build support for investment thesis or create new investment theses. And something that's really exciting is you can expand this to issuers that you do not currently cover to get a flag of what's likely to downgrade or upgrade. Now let's dive into the actual data science process, as this is a Women in Data Science conference after all. This is a chart of the data analysis process that I go through. So first, I try to figure out what data do I need. I wind up going out and getting that data, reading it, formatting it, and joining it together. After that, there's the feature engineering, selection, and manipulation, where I try to look at that data, create features that are actually testable. So when I say a feature, some people use the term factor, some people think about a column in a data frame, or just a column in an Excel table. That's kind of what I mean there. So you can create new ones or combine some together. Then I'll wind up going and splitting the data into train, validate, and test data to be able to use test data for my results. And you wind up looking at exploratory data analysis, and then you really dive into the machine learning, model selection, testing, tuning parameter section as well. At the end, I'll choose the final model, retrain, and test it on my test data. But what's really exciting about this project is that the idea was given to me by a portfolio manager on the high yield desk. Initially, the problem was a lot smaller, and we continued to expand it and test other things. Think about back to that experimental chart in the beginning that I showed. We then brought in an analyst who looks at this problem daily. So then we could make a tool and actually customize it to what he would want to use. He wound up helping with getting features and talking about how his process actually is. Throughout the process, we've been partnering with a great startup. They're called Forge AI, and they have a massive amount of data that I'll talk about on the next slide. And so that partnership was really crucial to help this project get along. And then capabilities of a data scientist like myself to kind of tie this in together to make this cross-functional team. This project is a great use case to test alternative data. So the question you really want to ask is, to predict an increase, decrease, or no change, what data is relevant? It falls into 4 main buckets of ratings, SEC data, news, and financial data. For ratings data, we get ratings data for S&P, Moody's, and Fitch, which are those 3 rating agencies we're looking into. Then we can think about where they're positioned. So what ratings do they have? What have they had in the past? What do we think they're going to have in the future? SEC filings. These are company filings that they have to file at different points in time. So 10Q is a quarterly company filing, 10K is annual, and 8K happens when there's a bunch of different events. And companies have to do these things. So then we wind up taking themes, events, and indicators out of these different filings and create features through that. The news data, similarly, we wind up talking to the subject matter experts on the desk and hearing what indicators they look for. So we use machine learning to include themes mentioned, sentiment, sector sentiment, events, different things like that. And the SEC and news data has come from that company, Forge AI, which has been really great. And the financial data is the last piece, where we wanted to get financial information and ratios that the desk cares about. But also we wanted to look at a more stereotypical model. So we research and replicate something called the Merton model, which is a standard model to assess a company's debt and default rate. And so we wind up using that and combining on these alternative data features to be able to add these and do feature ablation studies as well. Now that we have the data under control, we have to think about, okay, what model am I actually looking at? What do I want to make with this? And so this problem is a classification problem, actually a trinary classification problem, because you have 3 labels: increase, decrease, and no change. And also this problem is an unbalanced data set, meaning that most ratings don't change compared to the amount that increase and decrease. An example of this is in the pie charts below. On the right pie chart, think about your credit card and your transactions. Most of the time, your credit card will go on and work completely as normal, and maybe 1% of the time you'll have a fraudulent charge. And so if I were to predict everything on that right pie chart as normal, my model would be 99% accurate. However, it would miss 100% of the things that I actually care about. So that model would be useless to me. So that means that accuracy in a problem with this unbalanced data set isn't an appropriate measure. I actually wind up looking into terms like precision and recall, because you don't want to get into that cadence. Now for the actual model. The model that I chose is the random forest model. This model is really great because it's relatively easy to understand and has a notion of feature importance, where I can show that feature importance to the non-technical users. I'll get into a little bit more of what the output looks like in a bit. But so what is this model? Imagine that top cylinder as an Excel data frame with all of your data. Then I want to sample with replacement to be the same size of that data set. Say I do this 1,000 times, and that's the cylinders below. So each one of those data sets are slightly different, but almost the same. You end up creating a decision tree on each one of those, and then taking the majority prediction. So an example of a decision tree is on the right. Am I out of shampoo? Yes or no? Is it raining? No, okay, I have to go to the market. And so imagine constructing 1,000 of those and then taking the most likely vote. And so that's what this model is doing behind the scenes. Now, why do I think something like this would work? The model is based off of a lot of data. We have around 1850 or even more now, different companies where we have data going back to 2014 until now. So it's a really large data set. But this tool will be used by analysts and traders. So they want to understand what the model is doing and be able to see the results with that. So the feature importance, as I talked about before from the random forest model, can wind up providing some explanatory information, as well as some of those natural language processing features that were indicators, taking information from the news, taking information from SEC documents. That's a lot of the things that people would wind up searching the news and SEC documents for. So traders and analysts make decisions based on all of the data that they have. So this tool can wind up giving a prediction with some of this information, and then can act as a first pass, giving a flag, say, hey, take a look at this. And then the traders and analysts can layer on their own insight because they're really the decision makers at the end of the day. This whole project has been a large partnership with the desk. So partnering with analysts, traders, researchers, trying to figure out, okay, what is it that we really want with this? So this involves a really iterative approach in modeling progression. So we started with one model, the S&P ratings on the 1-year time horizon. And then we wound up expanding it out. So we expanded it to the other 2 rating agencies. We expanded it to other time horizons. 3 and 6 months, we also tested larger time horizons. And all of this is rapid and iterative experimentation just to see, hey, will this work? Will this not? But as much as the model is important, the explainable information and being able to play with something and actually feel the model is really important. So traders and analysts need to believe the model. So we wind up including an output that has company financials, top features, themes, and indicators, and we put that in. So at the bottom here in this image, there is, think of this as an Excel document where you can have all this information in it. And this is something that we would call a proof of concept, where I can create a prediction, put it in an output for Excel, spit it out with some of these different indicators, and then show it to people. And so that's how we do a lot of this rapid experimentation by small tools like this. And then this type of simple tool enables people to use this to make decisions. They can ignore it if they want, or they can use this flag as something to layer onto their own insights. So that's one of the examples of a project that gets submitted to our team. There are many different types of projects and experiments that wind up coming to our desk. So I'll dive into a few of those. People from all over the investment management group will wind up submitting ideas to our team based off of problems or issues that they have, or they read a paper and find something really interesting. So some of those range in the realm of natural language processing. The previous experiment I talked about before was more of a predictive analytics type bucket. And all of these kind of combine to one another. But some of the projects and experiments I've worked on, have to range with clustering, topic modeling, summarization, sentiment, name entity resolution, you name it. And so how these ideas work is, for example, the summarization and sentiment. SEC filings are large, sometimes boring financial documents that people have to read and go through because they have really valuable information in there. So, can we parse that information? Can we wind up getting sentiment? Can we summarize those documents? Those are some types of different experiments that we wind up working on with the desk. Or, name entity resolution. Can I make a bunch of different names, HP Inc., HP Corporation, all go with Hewlett Packard? But can I do that for a universe of only the companies that I care about with my terms? Because a lot of times when you have data sets, you won't actually have an identifier that maps them to one another. So these are some of the different types of experiments that people wind up getting to us. And another really interesting frame of work that I've worked on in the past is with network analysis. And so with network analysis, there's many things you can do in the investment space. You can think of each of those nodes. So one of the circles on this graph is called a node, and the line in between that is called an edge. And so you can think of each node as an individual, as a company, as anything that's connected together. And then with that, you can wind up looking at network contagion, sentiment, events. Think about even with COVID, you can wind up talking about who was talking about that first in the news, and can you wind up looking at the dispersion across that by companies that are all connected together? So with the team that I'm on and these different types of projects, data science is really broad and no two of the experiments are really alike. But I hope that you all enjoyed the talk about ratings and that this was exciting for you all. So are there any questions?
Yeah, we have a few questions, and as Carly answers some of these, feel free to drop more in the chat. So the first question that we have for you is, what has been the biggest challenge while developing this project?
The biggest challenge with developing this project is definitely the data. Trying to think about what data you need, trying to, as we talked about the challenges of data, cleaning it, making sure that you know everything. So for example, when I wind up pulling the data, there might be a rating. So, AAA plus minus. And so what does that mean on the end? And so each of those little things that's added on to the data might be an analyst projection. It might be some type of information. So the biggest challenge is looking at a lot of data that in the beginning of this project, I wasn't an expert on ratings, and then trying to understand what is meaningful and what is garbage, to try to figure out what's an NA or not. So that's probably the largest challenge on this project.
Cool. We have another question. What are some of the sources to extract the average sentiment feature?
So the sentiment winds up coming from this company called Forge AI that I partner with. And so you can take sentiment of, we have a large corpus of over 1 million news documents and SEC filings, and then think about taking the positive and negative sentiment from those. And so you can aggregate that up then by companies in a given sector or companies in a given group or talking about a theme. So that's how we wind up doing the sentiment. And we wind up testing all of those. Not all of those are included in the final model, but we wind up creating them and throughout the process wind up taking different types of sentiment that way.
Cool, thank you. Along the lines with data, in addition to the data sources you mentioned earlier in your slides, are there any others that the team uses for their projects?
Definitely. So our team, each project that we wind up getting has usually a different data set. For example, last summer with COVID, we wound up looking into unemployment. We wound up looking at Google Trends, unemployment website. We also use news there too, but also we'll look at mobility data. So there's different providers that provide data for that. So think about when people stopped going to malls, that impacts things financially. So we can actually use the underlying data for that. We also use a large amount of financial data to look at, rates prediction, inflation, different types of predictions of a different bunch of different things. But they usually go into the realm of there's financial data, which includes everything from prices, ratios, information like that. And then there's a large unknown of alternative data. And that's where some of those things like Google Trends data or mobility data, different things like that we'll dive into. So a lot of the experiments that I wind up working on, the first step is what is the data that I need and what's the data that's possible to get. And so sometimes you'll have a data set fall in your lap that happens and you think, this is a great data set. Let me go send this over to another data scientist so they can work on it. And so that's kind of how we wind up looking at a lot of the data.
Does working in such a regulated industry such as finance impact your ability to access data and build models as a whole? Are there any roadblocks that are posed simply from being in finance?
Definitely. I mean, so there are many data sets that I wish I could have access to that I probably shouldn't have access to and I shouldn't wind up looking for. And so, there is within a financial company, there's data on just about everything. And so, there are some roadblocks of access where, I won't be able to touch certain things. And that's okay. They're meant there for a reason. However, the really nice thing about my lab is that I'm able to access a lot of the alternative data. So even if you can't get one data set, there's usually something else that you can find. But sometimes there are experiments that get asked from our group where we can't wind up doing them because the data isn't feasible to get. And that's okay. In the future, I hope that all the data is available and ready to go, but it's also understandable. So the roadblocks are usually data access or data cleanliness. There might be access to data on the web in any which way, But if it's going to take you months to get that data set formatted, that might also be another roadblock as well.
And our last question is, can you use Lasso for feature selection in the ratings project?
Yeah, so Lasso is a great tool to look at when you're first starting to do feature selection, where you can run it through the model. You can run the model through and see what features it winds up dropping. And so in this project, I started out with over 500 features. And so in the beginning, a lot of those features have no relation to the end result. So you can use a model like Lasso to wind up taking away some of them. I wouldn't suggest that you only use that as your feature selection method, but it's a great feature selection method to wind up layering on with other things.
Awesome. Well, that's all the questions we have for you. So thank you
Awesome.
very much.
Well, thank you so much. You all will hear me more at the closing today, but take it away.
Thank you, Carly. That was awesome. It's so interesting to see the application of data science and finance. So thank you very much for your talk. It was great.